Matthew Teague, thank you for agreeing to be our speaker. He is the Senior Architect and Project Manager for Tata Steel. He has an impressive working history with the steel industry that spans over 22 years. As an architect, Matthew's work centers around how they, as manufacturers of steel construction products, can respond to customer requirements in a rapidly changing sector, and how design decisions can optimize outcomes on site during the project's lifetime, including end-of-life reuse and recycling, because steel is good that way, isn't it? Before joining Tata Steel, then Chorus, Matthew was an architect in private practice specializing in housing, and spent some time in London Transport as the design manager for environments. Recently, he's been involved in projects where design for manufacture and assembly, of course DFMA, has been employed, rather than more traditional methods of building, procurement and construction, and continues to work and invest in this field. Matthew and his family live in London. Both children are now at university. They've flown the nest yet? Or they're still staying at home? Oh, wow, bless you, good. Matthew builds bicycles outside the working week, also from steel, impressive, and is even occasionally known to ride them. I give you Matthew Teague.
Okay, I don't remember writing that, and I know what you're all thinking. He doesn't look that old. Right hand. So, it's a little bit of a diversion from the title of the talk to begin with, because I thought it would be worth exploring some of the difficulties we have as a steel manufacturer. It's quite nice to be in a room where pretty much everybody in the room uses your product. So we're a bit like, supermarket in terms of you guys. Everybody uses us. We are the largest steel maker in the UK. Most of our steel making operations are based in South Wales, where we have Port Talbot, which is a very large integrated steel works. And we have the capacity to make about 6 million tons of liquid steel a year. It's a little bit less than that now because of the pandemic and what have you. It's more like sort of closer to 4. But we invest very heavily in our local communities. So our contribution to the Welsh economy alone is in the region of 3.5 billion per annum. And we still directly employ about 8,500 people in the UK. We have several manufacturing sites. So apart from making steel, we also make building products. We make building products in North Wales at our Shotton plant, where we make things like steel decking, which you saw some of the steel decking on the forge just now, which was repurposed as a beam. We make composite panels, and we also make painted steel. So we make pre-coated steels of various types. We make steel for packaging in Trocester, also in Wales. We make metallic coated strip. And then over towards the east side of the country, I think Corby is a little bit further east than it's shown on the map, we make tubes. So we make tubes for construction, and up in Hartlepool we make tubes and pipes for construction and the oil and gas industry. So we're sort of very heavily invested in the UK. However, steel has a problem, and it's the elephant in the room really, is that steel is a very carbon intensive industry. So for every ton of steel we produce in the region of 2 tons of CO2. And that's despite being one of the more efficient steel producers in the world. We make steel via the primary process, which is blast furnace and then basic oxygen. And we're of the view that that will continue for some time, because steel will always be needed. The amount of scrap in the world does not satisfy the demand for new steel. So there will always be a demand for new steel. It's how do we make that in a more sustainable way, and in a way which doesn't leave us with stranded assets in the future. That's most important. So we don't want to invest in the wrong technology in order to move us forward in the carbon debate. So there's a hierarchy of actions, and this is where the DFMA story starts to sort of gain some traction in why we as a manufacturer are interested in it. So the first law, if you like, of a circular economy for steel is that we reduce overall. So we reduce carbon. So if you can reduce carbon whilst we make steel, that's fine. But if you can reduce steel in buildings, that's also a very good way of moving forwards. We can reduce the resource. We can reduce the amount of transport that's needed. So things like buying locally or buying steel which has been sourced from less far away, shall we say, is also good. And then there's steel weight. So it's already been mentioned that if you reduce the amount of steel, we reduce the necessity for other things such as large foundations or response, for instance, to overheating. So we can lightweight a building, we can make things generally more efficient. Next on that list is reuse. And as you see, as you go to the right, we have greater emissions and greater resource use in terms of energy to reclaim that piece of steel. One of the things we're very interested in is steel reuse. That's steel reuse directly from the end-of-life building. And we are talking to a number of recycling companies about just how we engage with that market, how we actually make it work without cannibalizing our own markets. It's a very difficult conversation to have with senior management who are sort of saying, well, why would we do that? And the obvious answer is, well, we would do it because we're good guys. Then we have remanufacturing, which is where we take a piece of steel and we do something to it. So we might turn it into some piece of steel for something else. We might take the end plates off. We might make an assembly out of it. But that involves some work, some remaking or turning it into something else, maybe for another sector. And then last of all, very last on the list is recycle, which is where we take the steel and we put it back into the process somewhere. So we either put it into an electric arc furnace and use electricity to turn it into new steel, or we put it back. We can put scrap steel but directly back into the basic oxygen furnace to make new primary steel. So not a lot of people know that most new steel is actually 20% recycled anyway. So there's always some recycled content in steel. This is our journey towards a fully sustainable steel, and it will involve a number of technologies. That's the other thing to note, is that there isn't a magic bullet for this. People are talking a lot about hydrogen, but you need a hydrogen infrastructure to use hydrogen, and there isn't really a hydrogen infrastructure yet. We need to work with other industries. And that's not just from our sector, that's not just metals, that could be from any of the other foundation industries such as glass or paper making or oil and gas or chemicals. And we're always trying to align to the Sustainable Development Goals, the UN targets. We're already members of Responsible Steel, and we are a member of the UK Green Building Council as well. So we are sort of trying to be responsible manufacturers. This is our integrated steel plant at Port Talbot. It's not that green. It does have a beach, though. Iron ore and coke, or coal, which is turned into coke later on in the process, come in by sea at the moment. We then mix them together in the sinter plant to make what goes into the blast furnace. That is then turned into liquid iron. Iron ore is turned into liquid iron, and then the liquid iron is turned into steel in the steel plant by blowing oxygen through it. And that's how we make primary steel. And that primary steel is then turned into coil, which is then sent out to become other things like cars or fridges or buildings. There are two pathways generally to becoming carbon neutral, which are in line with the UK government and Welsh government's climate goals. Both can use hydrogen at some point in their future, but at the moment we're looking at smart carbon usage, which is taking carbon and storing it and using it for other processes. You can make hydrogen from some of the carbon process, and you can use it to crack methane, for instance. Or we can directly avoid the carbon by adopting something like an electric arc furnace. The likelihood is that it will be a combination of those technologies in the future.
Can I ask you a quick question?
Of course.
You in your last slide, so you have to use scrap to do carbonless using reclamables.
This one. Yes. Arc furnace.
Because you're pulling the carbon out of the system.
Yeah, the idea here, and it's an important question actually. So the thing with steel made in the electric arc furnace is you need very high quality scrap. So one of the problems with electric arc metal is copper. So if you're getting findings from car reclamation, there'll be wires and all sorts mixed up, and you get copper in the steel. We can't use steel with a heavy copper load for very many grades. Construction steel in the sense of reinforcing bars, yes. but not for primary, certainly not for automotive either. They won't touch it. So we need very high quality scrap. That's one of the problems, is getting segregated scrap of high enough quality to go into that process. So that's one of the conversations we're having at the moment with the recyclers, is how do we ensure that supply, bearing in mind that these days most of it goes abroad. So we need to sequester that supply of high quality steel, make sure we can use it. So that's one problem. Thank you for the question. Decarbonisation transition, I promise you this is the last slide on decarbonisation. There are a number of routes. So the Southwest Industrial Cluster, which hopefully Sam will recognise, is part of the route where a number of heavy industries can group together, for instance, to use hydrogen economy, hydrogen infrastructure. We can use CO2, we can use bioreactors to turn waste industrial gases into other things, and there's another UKRI funded project down at Port Talbot to do that. We can use best available technologies, and an example of that is this turbine that's been recently installed, which is highly efficient and uses waste gases to make electricity. So we are also our own electricity manufacturer down in Port Talbot. As I've said, we're already members of Responsible Steel. The other thing you've got to do is measure how sustainable we are. At the moment, there's a UN program called Race to Zero, which we are looking to join, but it's very hard to measure our impact. There's no methodology for the steel industry at the moment, but we are developing one, which is called the Net Zero Steel Pathway Methodology. We've got to come up with another name. And last of all, there's zero carbon logistics. We've just come into possession of a hydrogen-powered boat, for instance, for moving iron ore and finished product around. So it's little chips away at the cake, at the carbon cake, if you like. And the story about design for manufacture and assemblies is kind of the same story in construction. In government, we've seen these long-term targets come out, so 33% lower costs, 50% faster delivery, 50% higher productivity, lower emissions by 50% as well. And then the projected UK government spend on construction, this is a fairly old graph, so it's probably changed, but it looks like that. So you see this massive drop-off in traditional to a huge take-up of platforms. And I don't actually agree. I think that volumetric and modular, which is here, I think that will actually be a bigger part of the cake than 10%, but it's just my opinion. All of our products have we've already seen. So the forge uses conform beams for their horizontal beams, albeit turned upside down and filled with concrete, which was a use that, it's one of those bits of serendipity that you sometimes get in the construction industry, where someone comes along and says, I think it was Jamie Johnson came along and said, do you know anyone that makes this? And we go, well, we do, which was great. But we also make, the hollow sections that are around the external frame of the forge as well. So we're quite heavily invested in the forge as a company, and we've been to visit many times. It's a very good building. If anyone can make it, not sure if you're still doing visits, but it's worth having a look at. And then we've got projects such as seismic, of which more later. Let's go back to that one, which is again a UKRI funded project looking at education buildings around a different route, a different delivery of a different sort of platform. This is a project we did with Neath Port Talbot Borough Council and a group called Specific, which is another government-funded catapult looking at buildings as power stations is their motto. So the upper floor and the roof are both generative in some respects. So the roof generates electricity, the wall generates warm air. The wall is something called a transpired solar collector, which is basically a dark piece of steel with holes of a very specific size drilled in it at a very specific pitch, which draws air in from it. So you get a boundary layer of warm air next to the steel, and this transpiration of the warm air travelling up the steel actually pulls it inside, and you get a plenum level of warm air, and you can then use that warm air to drive something else like a heat pump. Or you can actually directly, if in the winter, for instance, you can directly vent it to the building for warm air direct from outside. And the roof uses a flexible product by a company called BIP Vico that make a the cadmium indium based photovoltaic cell, which is flexible. So it's a self-adhesive cell that goes onto the roof. So that roof could be any shape within reason. It could be barrel vaulted, and we've done a barrel vaulted one as well. And that generates electricity. It's very good in grey sky, which is extremely good for Wales. And it's about 19% efficient, which is comparable to the silicon chemistry, which is used for most photovoltaics. Seismic, as I mentioned, this is our demonstrator down at the Building Research Establishment in Garston, which is looking at education buildings. And the primary feature of Seismic is a two-stage project. One was to work out how the frames would actually become interoperable, and the other one was to build the demonstrator, so that you've got the corner of the frame there at the top in the middle. And the salient feature about that is it's two volumetric manufacturers, McAvoy and Elliott, who are now called Algeco. With those on their modules, a normally incompatible system is now compatible. So you can use one modular manufacturer in one floor, for instance, and the other on the upper floor, or you can use, God forbid, if someone went bust, you could then switch to another manufacturer with a fully compatible product to a partially built building. On the building on the lower right, we have modules from McAvoy in Northern Ireland on the bottom, and Elliott's, who are based up in Cannock in the West Midlands, on the top, with almost no compatibility issues whatsoever. And then it's clad with various products from our cladding portfolio, just to sort of try a few things out. And then the forge, very lastly, the forge. Point of this slide is that normally on a building of this size, we'd be using a lot more Confloor. In fact, we'd be using probably about 30 times more Confloor than that, because it would be the whole floor plate. So the other thing we as manufacturers have got to get used to is saying, okay, that's great, why don't we use less steel? And it's how do we make the value proposition for that work? And it's to do about carbon, it's to do about, and sort of how we advance in a world which is rapidly changing in construction, to lighter weight, to more efficient buildings, to using platforms. And the last thing I will say is that basically this is all predicated on the idea that a building becomes a warehouse of its own parts. So we've talked about reuse. Well, this is a classic case for reuse, and Seismic actually is a classic case for reuse, in that if you want to move the building in the future, there is nothing stopping you from taking this apart and taking it somewhere else. There's nothing stopping you from taking it apart, taking all the corner nodes off and putting them in another new building. Although quite why you'd want to do that if you had a serviceable building that you'd taken away. So I guess the last point is that as steel manufacturers, we are aware of our responsibilities and our obligation to the future, and we're working towards it. But one of the ways we are working towards it is getting more and more engaged in this new way of thinking about construction, which is about kits of parts and using products directly from the manufacturer where possible. Thank you very much for your time.